welcome everyone to this session. We have a range of great speakers for you, and we'll talk about electricity and gas infrastructure and energy system integration. Before we start, just a couple of kind of housekeeping rules. We use Slido, as with any session, we use Slido, and please, to all the participants, please use Slido to ask questions to the panelists. And also, I would like to encourage you to vote for questions that you particularly like by pressing the thumbs up, and that means that the most popular questions can be addressed to us. So we have a program also including 2 polls, and of course, an invitation to all to be active and participate to these polls. Before we properly start, I would also like to introduce briefly all our speakers before we move to the presentations. My name is Daan Peters. I'm a director at Guidehouse, an international consultancy operating across the world on the various topics. We have 700 energy professionals. Myself, I'm mainly active in the field of decarbonization of infrastructure of the energy system, and I advise a range of clients both in Europe and North America on the decarbonization of gas infrastructure, the future of gas. I would also like to introduce Jan Ingwersen. Jan is General Director at EUSEW, the European Network of Transmission System Operators for gas. He's been working there for the past 6.5 years already in various capacities. And at the same time, he's also leading the international branches, international director of the gas division at Energinet, the Danish gas TSO. Jan has a deep understanding of the gas value chain, and earlier in his career held various managing positions. So great to have you on the panel, Jan. Then also we have Bojana Achowski, Secretary General at Gas Infrastructure Europe, the voice of Brussels of the TSOs, gas storage operators and LNG terminal operators. Bojana has been at GIE for the past 7 years, and before this she was active at Bulgar Transgas. Then we have also at the panel Paolo Gallo, President of GD4S, a group of 7 large European gas DSOs, gas distributors for sustainability, from 7 EU member states, with the aim to raise the voice of gas DSOs in the Brussels debates, and also from a perspective of facilitating decarbonization. At the same time, Mr. Gallo is also CEO and CEO of Italgas, the largest Italian gas DSO, who operates almost 70,000 kilometers of gas pipelines. And at the same time, if this were not sufficient, is also a professor at the Louis Business School in Rome. Then we have at the panel also Leonardo Meus, a professor at the Vlerik Business School in Belgium, and also associated with the Florence School of Regulation. He directs the Vlerik Energy System. He's a member of the International Association for Energy Economics, and also frequently publishes in academic journals. Then we have Dimitrios Giannitios. Dimitrios is chair of the System Development Committee at ENTSO-E, managing a team that coordinates ENTSO-E system developments. And he's also a senior advisor at RTE, Réseau de Transport d'Électricité, in France. Then previously not on this panel, but should be on this panel also Anne Boersma of ENTSO-G. I think that Dimitrios will also be able to cover Mr. Boersma's section. So I would like to start with briefly talking about an initiative called Gas for Climate. So maybe we could go to the next slide. Yeah. So I would like to go to the Gas for Climate slides. So I'd like to briefly talk about housekeeping. Sorry, could we please go to the, yes, here we are, thank you very much. I would like to briefly talk about an initiative, Gas for Climate, a coalition of 10 gas TSOs and 2 renewable gas producer associations that is since 2017 active in analyzing the future of gas and gas infrastructure in Europe. Maybe at the next slides we see the logos of the various companies involved. And also to create awareness of the future role renewable and low carbon gas in the energy system. Maybe to the next slide, please. So recently, Gas for Climate published a study in which various decarbonization pathways were analyzed from today to 2050 towards a fully net zero energy, net zero emission system in 2050. And basically the slides that I wanted to show here is what we see happening in the first decade between 2020 and 2030 in terms of gas infrastructure, and then moving on between 2030 and 2050. So basically in the study, and the study is called Gas Decarbonization Pathways 2020 to 2050, we basically modeled, and I was personally also involved in supporting the creation of this study. We analyzed, okay, what would happen with gas infrastructure when scaling up hydrogen, biomethane, renewable low carbon gases, and also going into various demand sectors. So what will happen in terms of implications to gas infrastructure? So then in the first decades, gas infrastructure is still dominated by transporting, storing and distributing mainly natural gas, but including quantities of biomethane. And at the same time, we see industrial clusters where hydrogen is already produced today, where larger projects of blue hydrogen, it's combined with CCS, and the initial large green hydrogen projects based on renewable power emerge. And this can lead to also around 2030 to the first dedicated hydrogen infrastructure. On the next slide, we see how, according to the study, the gas infrastructure may evolve in the years 2030 to 2050, ultimately resulting in 2 parallel infrastructures, a dedicated hydrogen infrastructure and a dedicated gas infrastructure, methane, biomethane, power to methane infrastructure. So we see that increasingly the injection of biomethane increases, the injection of green and blue hydrogen increases, and all this connected by 2 infrastructures. The dedicated hydrogen infrastructure would be mainly based on retrofitting existing gas infrastructure. And we see that would be possible going forward, as there is in many places in Europe parallel pipeline systems that ultimately could be retrofitted to dedicated hydrogen infrastructure. So this is a snapshot of a study we did with the Gas for Climate Consortium. One of many studies that have been brought on the attention of the European policymakers. There's a lot more to be said about gas infrastructure, but surely about electricity infrastructure and how both infrastructures connect. That will be the main topic of the session today. So I hope that it will be a very lively session with all of you. I would like to go now to the first poll. And the first poll is basically the question, what is the most important consideration in the revision of the current 10E regulation? So we know that the Commission will update the 10E regulation. Is this, firstly, TSO, DSO coordination at national and EU level? Is this the need to refurbish and upgrade gas infrastructure? Data collection for national plans? PCI criteria on sustainability? So which of those will be the main And I see that voting takes place already. I will leave it a little bit more time before I ask some of the panelists to comment on the results of the poll. For now, there's a clear view that the need to refurbishment and upgrading of gas infrastructure will be a very important consideration in the version of the current 10E regulation. I think we can close the poll. And I would like to ask maybe Jan Ingwersen, could you comment on the results of this first poll, please?
Just some short comments. Of course, a part of this is also it will be included in my presentation in a few minutes. But I think it's for me it's not a big surprise that it's pointing out that this is important. Today, the European gas transmission infrastructure and distribution infrastructure is transporting almost 1/4 of the energy consumed in Europe. So it's a huge assets that we have as Europeans in our gas grids, and of course we should utilize that. And there are some obvious opportunities to do the transition, the green transition, in a cheaper way by doing that than and combining with all kinds of other transition initiatives, including electricity initiatives. So I think it's an obvious priority, and I fully agree to it.
Okay, thank you very much. Is there one of the other panelists that would like to comment? Otherwise, we will move to the next presentation. Great, thank you very much. So we will now proceed with two presentations, one by Jan and one by Bojana, both focusing on the energy transition. So basically bringing the TSO, SO, and LTO perspective on sector integration and energy transition. So really curious, Jan, what you have to say. You have 5 minutes.
Thank you very much, Dan. Could I have the first slide, please? A very basic question, of course, and we already touched upon that in the Slido. Why are gas grids relevant in the smart sector integration? First of all, I would like to say that I welcome very much the discussions, the debates, the political awareness that the gas infrastructure is a key parameter in the green transition. It is obvious that electricity, and Demetrius will of course agree with me in that electricity will play a very important and absolutely increasing role in this transition. However, we also agree that a part of the transition will not be done by electricity. Of course, we can discuss in length how much is electricity and how much is something else. But I mean, we are probably landing in the neighborhood of 50% depending on your viewpoints. But I don't think that is important. The important thing is that gas grids are here to play an important role for the future, representing a high potential for long-haul transport of gases, of storage of gases, and potential, of course, of switching from natural gas to biomethane and to hydrogen. It's a cost-efficient way of doing it, even though we do not have the full picture cost-wise yet, because it's only relatively recent that the bigger scale hydrogen plants have been really discussed in a serious way on a European perspective. But it's obvious that utilizing and converting existing facilities is an efficient option in the transition. Whether it's then done via biogas, where we are using the existing grid, whether we are using a blending of putting some parts of hydrogen into the gas grids, or whether we are repurposing existing gas grids. I think all tools here, all technologies will be applied. Of course, it's also here important that it represents a lot of jobs in Europe, and it's physically connected and related to Europe, and therefore an important element, not at least in these economy recovery times. Then in relation to why it is relevant, of course, the climate perspective is an important one. And already with the existing systems, a coal to gas switch will be in many countries a tool, a mean to achieve substantial carbon reductions very fast, and then maybe later on even going further with biogas and hydrogen. The gas can be used again here in whatever form, whether it's natural gas, whatever, or hydrogen or biomethane, to decarbonize the energy-intensive industries of Europe. And I think we have reached out to a number of those industries, and they are very interested in discussing with the gas sector how to achieve this. And finally, supporting the low carbon markets with looking into how to market the hydrogen that is coming up. Should it be one gas market where we're virtualizing the technical differences, or are we talking about maybe two markets? I think in a virtualization and with new technology, it should be possible to develop one market and to build on the benefits that we have achieved with the European gas market and the European gas prices in the recent years in the competition. So it's obvious to try to look into those options. Next slide, please. We are by now saying that gas grids are relevant. We are of course looking into the key legislative or strategy related initiatives coming up from the EU Commission, the energy sector integration, the hydrogen strategy, and the 10E revision is also coming up. So these three important elements we have been looking into with this approach. And I'll not go through our comments here, but you can see how our key points will be focusing on the sector coupling, looking into how to build on both electricity and gas. We are looking into the hydrogen strategy, where we think it's necessary to build all types of hydrogen, not only green hydrogen, also blue hydrogen, and probably also in a period of time, gray hydrogen for the transition. And finally, we have to connect and to integrate these considerations in the 10E revision, the criteria that will be used for choosing the projects of European interest, which will have the European support. So I think it's obvious why we think it's important to integrate and to look at these three pieces of EU initiatives in a consistent and coherent way. Next slide, please. And that's why, or part of that has been that we half a year ago launched what we call the EUSEW2020 roadmap for gas grids, where we are looking into how to prepare for this transition. We have identified three pathways to do that: a methane pathway, a hydrogen pathway, and a blending pathway. We think all of these pathways will be relevant in different parts of Europe. Maybe the methane pathway and the hydrogen pathway are the main ones, and blending will be a transition. We will have to look into that, and we have to address all the different regulatory and market and technical aspects which are related to this. And we have started that in the process with some 3 workshops here in the spring, and we will continue to build on the learnings from these workshops and also to call for new workshops here in the autumn, when we also know more about the content of the new EU strategy.
Thank you, Jan.
I think I'm done.
Excellent. Thank you very much. Bojana, let's go straight to your presentation now.
Yes, thank you very much. And first of all, thanks to Jan by presenting this perspective very well. And taking into consideration the limitations of the time, I will try to jump immediately to the storage and the LNG perspective on the decarbonization process. So we see actually gas storage really as a kind of a main, if we can move to the other slide, please. As a main cross-sectoral flexibility tool in the energy system, considering that in the electricity system, gas storage will play a kind of a increasing role as additional flexibility will be really required with the development of the renewables and the strong electrification that is expected. Such kind of contribution can be assessed in the terms of avoided costs in the electricity system, being on operational or investment kind of terms, by avoiding, of course, the risk of distraction, which is here very important. Such kind of contribution of the storage is very important, as security of supply for electricity is increasingly linked to the role of the gas storage. In hard to electrified end user markets, gas storage is really the main tool to provide kind of a large-scale capacities, from the flexibility that the storages are providing, the intra-hourly up to seasonal needs, and the avoided costs that I already mentioned can be assessed in terms of costs of the gas system, here including also the important role of hydrogen or hybrid system in the future, and avoided risk of the disruptions of the system. Here in the slide, you can see the number of the studies of the cells, several studies. Some of them were also presented in the Madrid forum that GIE had carried out to try to, let's say, to explain how gas storage could support the decarbonization. We actually kind of separate them in two different perspectives. One is the qualitative one studies, which was carried out by PODI and FTI Consulting, which really enabled to explain how storage could benefit the society by supporting the decarbonization. Where here it's really saying that I would like to emphasize once more that the regulatory framework that could fit the gas storage has also been tackled, and it's very important, the recognition of the role of gas storages. And then the quantitative studies, which was done by Artelis, and the analysis which we did together with NTOC, and once again, thank you for that, that really demonstrated that such kind of contribution of the gas storages can be assessed and well understood in kind of helicopter view, which is very much expected and required in the new integrated energy system and the sector integration. So saying that, we really see that the main contribution of storage will, in different sectors, it's like, let's say, the main facilitator to the cross-sector flexibility that can make the most of the synergy between the different sectors, namely here the electricity, gas, and the end user markets in the dynamic approach, which is expecting while optimizing the energy system and also emphasizing on the ensuring, let's say, security of supply. Saying that, I would like to move on the other perspective, which is coming from our side, and to elaborate a little bit more how LNG can contribute to decarbonization processes. Next slide, please. Because in the long term, LNG terminals have a great potential to be import gates for renewable energy sources in the form of liquefied form based on a very well-proven, let's say, business model through the assets that they're carrying and the capabilities and also the expertise that the LNG terminals are having. And last but not least, considering their location close to the industrial zones, we really see that the LNG terminals are probably very well and maybe best positioned to develop a kind of a new services that could make a great contribution to the energy transition in the, let's say, the circular economy. So I would really like to emphasize on the fourth pathways that we consider here as a possibilities. The first one is how we can decarbonize the gas upstream, let's say. So here in this pathway, the renewable gases being biogas or the green hydrogen, it's produced outside Europe, but so before to be liquefied and shipped to Europe. So in such kind of forms, it could be shipped in the form of bio-LNG from biogas, or the form of synthetic LNG with the conversion of green hydrogen and methane. The second one is more focusing on decarbonizing, let's say, the gas downstream. And here with this option, the decarbonization is actually done in the LNG terminals location, where you have the natural gas who is shipped from the European LNG terminals, and it is converted to so-called blue hydrogen via methane reforming or the pyrolysis. On the
Can I ask you to wrap up, please, Bojana?
Yes. On the first option, the renewable hydrogen is produced outside Europe, but still in location with high renewables, and then you have shipped it via hydrogen carrier. The fourth pathway is using the e-fuels, where you can have converted pathway renewable hydrogen into e-fuels, which such as ammonia and methanol. And in this perspective, the e-fuels can be used at the end. I'm happy to elaborate a little bit more on how do we see this in next in the discussion, as the time is running out. Thank you.
Thank you. Thank you very much. And I suggest we go to the Q&A, the Slido Q&A, to take the top questions that have been posted. So the first one, how much energy is lost due to old infrastructure distribution, and how much can we save by upgrading? The question doesn't clarify whether we talk about gas and or electricity infrastructure, but given that we so far mainly talked about gas infrastructure, I take it that this is on gas infrastructure. Can I ask maybe someone from the distribution side, Paolo?
Yeah.
Could you say something on this question, please?
I mean, the difference, there are several differences between in Europe. What the DSO have done in the last couple of years, a great effort to reduce the energy lost. The example that I can bring to you is what we have done in Italy. We have introduced a completely new and digital way to find out leakages to reduce the energy lost. And we were able to, in our regulation system, there is a bonus and penalties, depending which is the amount of energy lost. We move from the penalty side to the bonus side, meaning that we reduce the energy loss, so the gas leakages, more than the level that our regulatory was looking for. So, and I will talk later about the digital transformation of the network. Digital transformation is a great help, and I think it's also true for electricity distribution to significantly reduces the losses in terms of energy, either in terms of gas or electricity.
Thank you very much. Let's go to the second question. As Russia is a large supplier of fossil fuels to Europe, how will the transition alter EU-Russian relations regarding the Russian economy and the EU goals? Jan, would you like to take this one?
Yeah, at least thank you. I can start it. Maybe others have comments as well. Of course, that is true. Russia is supplying more than around 30% of the European gas supplies. So of course that will be an important part of the whole equation. I think it's also a matter of bringing in the suppliers in general, Russia as well, also as a supplier. Together with the rest of the value chain in the gas sector to go into this transition. And we know that Gazprom they are already doing technology development on pyrolysis technology in order to decarbonize gas and take out hydrogen and separate hydrogen and the carbon content. So I think, of course, it's a challenge. It's a long process that you need to go through. But I mean, this transition in general would call for close cooperation along the full value chain, whether it's with the suppliers, with the infrastructure, with the consumers, with the appliance producers. So I think it's a good question, and we will work on that in the coming period.
Thank you so much, Jan. Let's move to the next presentation, also with view to the time. Could I invite to put up the next slide, please? Paolo Gallo, GD4S, please give it away. 5 minutes on the distribution system, the gas distribution system.
Yeah.
Please.
In order to save time, can you skip a couple of slides? I will not talk about GD4S and Italgas because you can find the information on the material that is made available by the organization. Can you move on? Next one. Okay, that's it. No, previous one. Oh, previous. Okay, that's it. The first. So, I mean, that is the first slide that I wanted to share with you, saying that there is a growing consensus among European institution operators and national regulator that the goal of a fully decarbonized energy production in 2050 may only be reached with the cooperation of all the energy sources, meaning electricity and gas. There is also recognition by the electricity DSO that said sector integration between electricity and infrastructure and gas infrastructure and the feature of injecting renewable gas into the system can provide a good technical solution while reducing the cost of energy transition. The fact that the energy consumption is extremely high, that means that you cannot satisfy only with electricity. I put on this slide some number. The overall energy consumption is 7,500 terawatt hour, 60% of which is ensured by the gas. But furthermore, natural gas ensures, you can see on the right part of the slide, most of the flexibility needed to cope with the infra-annual energy demand fluctuation and intraday renewable electricity variability. In addition, I mean, the extensive, being the network of gas very extensive, and every corner in the continent is supplied by the gas, can guarantee the necessary vector of energy toward everybody. Let me move to the next slide. So, insisting in a very theoretical scenario where you fully decarbonize the electricity, you can insist, but it's not realistic. Because let's review some number. You can see if you plan the elimination of coal and nuclear power plant production, the electricity sector will require an additional 1,400 terawatt hour. Of course, you can solve the problem using natural gas, using renewable, But even when you have solved the problem to supply such amount of energy, then you need also to solve the problem to deliver this amount of energy. In that case, the study that many studies that have been carried out estimated an average cost in terms of investment between 9 to 11 billion on the electricity network. So the question is, why investing such a huge amount of money when there is available an extensive gas network? In addition, there are several estimations. DG Energy, but as well as France, as well as Italy, estimate a very large potential market for renewable gases. And that has to be leveraged in order to move toward a full decarbonization. If we move to the next slide, there are a role that the DSO should play in this scenario. In order to play this role, we need, as a DSO, to make a significant investment in changing the way that we manage the gas network. In particular, the major effort should be in digitizing gas network. And I wanted just to share, and that is on the right side of the slide, what Italgas has done in the last 3 years. We have completely replaced the smart meter, the old meters with the smart one, 7.6 million. We are in process to fully digitize our network. All the equipment will become digital. We have introduced, we started the digital factory to design and implement digital solution. Moreover than that, we have invested and we are going to invest 1 billion euro in the next 5 years. Let me finish with some suggestion from a regulatory point of view. Operators like DSO need the right signal from laws and regulation. And there are some suggestions we put regarding this matter. The gas grid investment in the extension should be considered consistent with EU legislation and funding opportunity because of their ability to support sector coupling, hydrogen production and distribution, and green gas development. We think that is extremely important to support power to gas and renewable gas production project, as well as digital and technical adaptation of the grids in order to adapt the grid to such evolution. From a regulation point of view, we feel that as a gas DSO, we should create a DSO entity at the European level that has to be recognized by the European Commission, able to cooperate with all the European institutions in dealing with the increasing complex energy system. Finally,
would you wrap up, please, Paolo?
Finally, I want to just 1 minute, less than 1 minute. Finally, we feel that laws and regulations should support biomethane production, fixed target for renewable gases, and then having also objective regarding power to gas project and hydrogen project. Thank you.
Thank you very much, Paolo, for this presentation. Now, let's take a look at the electricity DSO side. So, Leonardo Meus, Florence School of Regulation and Florence Business School, very curious to go to your presentation. Please, you have the floor.
Thank you, Dan, and thank you to all the organizers to invite me. Happy to talk about the DSO perspective, focusing on DSO TSO coordination. So let me kick off immediately. Next slide, please. I wanted to start by reminding all of us that the clean energy package was a big change for electricity DSOs. Their role has increased significantly. They've received new responsibilities. We refer to it as local congestion management, and that includes procurement of flexibility by DSOs. And it's this element of flexibility procurement that I say I will say a few words more in detail. But before I do that, it's not only about flexibility. There is more going on. We just heard Mr. Gallo asking for an EU DSO entity for gas. The one for electricity is currently being established, and that entity will have a role to draft network codes, of course, in cooperation with EUSEW. And two of these codes or acts are already ongoing. So we have the interoperability acts for consumer data services, which has been triggered by specific articles in the electricity directive. And you also have some ongoing work on demand side flexibility. So DSOs are already in that position because these are codes that will touch very close to their activities. And as we all know, there is the 10E revision going on, and maybe there will be some additional ideas on coordination for planning. So we already have the 10OA NDP. We have a provision in the clean energy package that talks about electricity DSOs developing multi-annual distribution network plans. And of course, the next question is, how do these multi-annual network plans integrate with the exercise we already do for transmission at the European level? So you could say largely three areas of TSO DSO cooperation needed. One, flexibility. The other, acts and codes, including close to the topic of digital data and network planning. But let me say, next slide, please. A few words more about flexibility. Why in electricity, for electricity DSOs is flexibility so important? Well, we see more and more studies, a bit like the gas for climate study. It's important to have these kind of studies to have a better feeling of impact, what's coming. So what's coming in electricity distribution grids is, of course, a combination of solar and wind, decentralized renewable energy sources, electric vehicles, and possibly also heat pumps if we decarbonize. As Jan said, maybe part of it will be to electrify heating, maybe not all of it, but at least part of it. Now, then the impact is either you do a lot of network investments or you try to save some of those investments by using flexibility. And then we talk about flexibility mechanisms. We can try to make retail prices more dynamic. We can do something on network tariffs. But more and more, I think everybody agrees that we will also see DSOs procuring flexibility services. And this can be done through more long-term smart connection agreements or also on a shorter term. And it's especially this shorter term, what we then call flexibility markets, that require some coordination with TSOs. And that's my next slide, please. So we always talk about electricity markets as a sequence of markets, right? And then the big question for the future is, where do flexibility markets fit in? And here I should mention another project we're involved in on TSO DSO coordination, the project Interface, which has several electricity DSOs, but also electricity TSOs, and also EUSEW is there. And in the context of that project, we already looked at what different countries are doing, and we see that in some countries, flexibility markets are a bit like balancing markets, with DSOs procuring grid services. In other countries, the DSOs are sourcing their flexibility in intraday markets, or potentially even in the national redispatching market. So we are very far from a unique approach, and that's why it's a topic that I'm following very closely, and I'm very curious to see how all that will materialize. Thank you.
Thank you very much. Maybe we can take some questions. Maybe we can move to Slido. But before we do that, first of all, the second poll. So we have a Slido poll, and please vote on this one as well. So the poll is about what is the most important challenge that gas and electricity DSOs must face in sector integration. So is this complete network digitalization, coherent intersectional planning of future network developments, coordinated TSO and DSO planning at local level due to the expected increase in decentralized energy production, or play a more proactive role in the development of new technologies? So great if all of you could vote. So let's wait a little bit. What we could do? Yeah, let's wait a little bit before we move to the Q&A sessions. Okay. So please close the poll. And sorry, can I go back to the results? Yeah. So there's a clear winner in terms of coordinated TSO and DSO planning at local level. Maybe Leonardo, you would like to briefly comment on this?
Yes, indeed. And well, I think I agree that this is definitely a big challenge. We've seen, that it took a while for TSOs, both gas and electricity, to really develop this kind of more harmonized approach to planning at the European level. It's normal, this takes time. We had well-established national practices, but then the big challenge was how to have a more coherent approach at the European level. And now we're only starting. So for TSOs, it has taken several years, right? And we're still discussing 10Y and of course, it can still be improved. So that process is going to start now for electricity DSOs. And only that process in itself, independent from each other, is already a challenge. So if you then also want to put them all together into a more harmonized approach, I think that will be a big challenge. I think it's also the next speakers will talk about their experience probably in developing joint scenarios. I don't think that's always easy to do that across sectors. So if we would need to do that, also a TSO, DSO, joint scenarios and a joint, more harmonized approach to cost-benefit analysis, I think we will still have some interesting discussions in the coming years.
Thank you so much. I suggest we take some questions from the audience due to the Slido. So maybe we could go to the Q&A and see what top questions came in. I hope that many people also pressed the kind of thumbs up button. The most popular question: where should biomethane and hydrogen be injected? Into the TSO network or into the DSO network? What are the panelists' views about blending? So maybe, I would like to ask a couple of responses. Maybe first Jan, and then Paolo.
Thank you, Dan. I think we will see both. Of course, a lot of the both biogas and hydrogen will be produced locally, but I mean we will also have the challenge of the production will be also in other places than the consumption, and we will also need to create the security of supply. We'll need to create the market interaction. So I think we will see both. But of course, a lot of biogas will be injected in locally, of course, and hydrogen the same.
Thank you, Paolo Gallo.
Yeah, I'm just following what Jan has said. It depends where is the production. We have seen in Italy both biomethane injected into TSO network and also onto the DSO network. The point is that you need to have a real digital network to accept biomethane. It's the same for the hydrogen. We have experience in Italy blending about 10 to 15%, between 5 to 50%, to be honest, about hydrogen blending with the natural gas, and it works. Again, in order to control all of that, you need to have a truly digital network. Otherwise, you will not be able to manage either the biomethane and a blending of hydrogen and natural gas.
Thank you very much. Let's go to the next question. What is currently the main challenge in integrating hydrogen into the grid infrastructure? Jan, I think this is again a question to you.
Yeah, again, I mean, here we are talking about a very, very broad challenge. There's some technical issues. We had one of our workshops were around that one. So there are some technical issues that we need to deal with. We have the belief that we are capable to deal with it, to find solutions. So that's the technical part. Then we have the market part that we think we have the conviction that we should avoid going into a development where we're creating local monopolies of hydrogen production, but we should definitely look into how to create a consistent and connected market. And I fully agree with Paolo that the digitalization, not only of the DSOs on the DSO level, but also on the TSO level, is a very important component here in order to create and to be able to track the different gas components, to track the hydrogen, to track the production of it, the character, you could say the climate value of it, as well as the energy value of it. So there are both technical and market-wise and digital challenges. Thank you.
Thank you very much. Let's take one more question. What is the role that large-scale, long-duration electricity storage has to play in sector integration, and how should this role be recognized in PCI-CBA? Dimitrios, would you like to take this one?
Yeah, thank you very much. No, indeed, long-duration electricity storage is an issue, especially looking at certain countries. It's not a widespread, let's say, consideration, but in certain countries, you should be able to deal with it. Now, in the current setup of the CBA, it is not modeled. It is not part of what we consider as a benefit at this point in time. Again, because it's a kind of a long-term issue, and we need to address it properly. I think in the long term, it should be recognized in the CBA as long as the methodology is proper to do so.
Thank you very much. Maybe one last question. Should a hydrogen backbone pipeline infrastructure across Europe be considered as an important project of common European interest? Bojana, Jan, maybe a quick response from both of you. So basically, yes, no, or with a... Bojana, would you like to take this one?
Yes, well, basically in our side, we are discussing, how to say, the change of the existing gas infrastructure on considering the fact that it can be reused of using the hydrogen, and there are very good examples which are coming from the Netherlands in this perspective, where the first natural gas pipeline was already reused for the usage of hydrogen. Of course, the question is if a needed infrastructure for hydrogen have to be considered by the infrastructure, it's taken into consideration by our members. But if this needs to be reconsidered as PCI, probably Jan could answer better than me.
Jan?
Very short. I can see time is running out. I think what is important right now is to consider the hydrogen backbone as a concept. Of course, it will not be a grand physical plan to be rolled out on a European scale, but it's about having the idea, the concept, the vision of connecting the pipelines in a way where we can use it for both security supply and markets, but it will not be a physical project. It will be more concept, and we need to consider the regulatory implications of this as well, both technically and market-wise.
Thank you very much. I suggest that we move to the next set of speaker, or the next speaker, I should say. Dimitrios, can we go to the, yeah. Originally it was foreseen as a dual presentation, but I would like to invite you, Dimitrios, to cover all the slides here. The floor is yours.
Anna has joined. Anna has joined.
But I think I got a glimpse of Anne before, so just to confirm.
Anna, are you on?
There you are. Okay, so we'll do it as planned.
Yes, right.
I did not turn on my camera because the Wi-Fi is low. Yeah.
Okay, let's. I'll pass the floor to Anne right after my first slide. Thank you very much for the invitation, and thank you for the opportunity to speak. I think the title is Scenarios and Smart Sector Integration, and we are talking about smart sector integration as something of the future. I think our presentation here is to show that smart sector integration has started, and the common scenarios by two very distinct and separate industries so far, gas and electricity, is kind of a breakthrough that has been going on for 4 years now in terms of integration. This is the first and probably the most important step in sector integration. If I go to my first slide, I don't see it on the screen. There it should be, and I will not go, of course, in detail. But what are the ingredients when we talk about smart sector integration? And I mean, the industries were integrated. I mean, they were coupled before. There were elements that were coupling the industries before. The question is whether these interlinkages are important enough to be worthy of modeling. And this is actually what we're doing with the scenarios. We just model the interlinkages, and we do model the two systems together. Having this one system view is quite important when you enter the scenario building exercise. And I think this is one of our biggest contributions as engineers, as engineering associations, to give this aspect of proper capturing of the world and modeling whatever needs to be modeled. I think, again, when we talk about multiple sectors, and sometimes the previous speakers hinted to that, neutrality is a quite important thing when you're drafting the scenarios. And why I'm saying that, because our scenarios are not leading policy, we're not leading markets, and we're not leading technologies. We're lagging. We're trying to reflect what we think is our best assessment of these things in our scenarios. And therefore, by definition, they should be plausible futures, not what should happen, but what could happen. And this is what we're presenting in the scenarios. Transparency is a major issue, and it's one of our greatest aspirations. And I think we have done a quite good job in being transparent on the way we built the scenarios together with ENTSOG. And this transparency, again, we shouldn't lose sight of what the purpose is. The purpose is to reflect how regulated infrastructure is to develop in light of the developments on every other sector. And transparency is the major objective that we have there. This is what drives the investment cycle every 2 years. And this is kind of the DNA of what we're trying to accomplish. Now, moving even further, and this is the last thing I'm going to say before I pass the floor to Anne, is that at least for the electricity sector, integration is not limited just to gas and electricity. Other sectors like heat, like transport, there is enormous potential to exploit synergies and to exploit joint, let's say, developments of things in order to help each system together, minimize investments, and have quite a sound and reasonable cost of developing the infrastructure. So smart sector integration, gas is kind of a priority at this point in time, but we're looking even further and opening, let's say, our scenario building to other sectors and consulting largely and fully is one of the big objectives that we have for the future. That's it. And Anne, I think I left enough time.
Yes, hello. Could you have the next slide, please? And indeed, it is, I can say that our work together as ENTSOG and ENTSOE, we have done this now for our scenario work. And it was an interesting experience over the last 2 years. And in the past, maybe it was relatively simple interaction. The electricity needed some gas for generation. And that was about the interaction. But now in this scenario cycle, we have experienced that there is much more interaction that we have to understand. And of course, one main component there is going the other way around. And that means the power to gas. Before I go into that, I would like to explain what were the storylines that were selected for our both T1DP scenarios. And there are basically 3 storylines, and the one on top you see is the national trend scenario. That's the one that is important for the European Commission. It is aligned with the national energy and climate plans, first with the draft and now, as far as possible, with the final editions of them. And that means that this scenario is also in line with the currently standing EU energy and climate targets, and also with, say, the official current long-term strategy of 80 to 95%. So you have to understand that this was the storyline was developed about 2 years ago. So that was before the Green Deal. However, next to the national trend scenario, we also have done two what we call COP21 scenarios. So scenarios to be aligned with the Paris Agreement, and even to the 1.5 degrees Celsius target with a high probability, and also to take into account carbon neutrality by 2050. At the moment when we started this, of course, EU had undersigned the Paris Agreement. However, it was not yet reflected in official policy documents. So by now, we of course see with the Green Deal and all the further regulation that's coming from that this COP21 level of ambition is now becoming the EU policy. So in that regard, it is good that we had these storylines included, so that we already can test our infrastructures, gas and electricity, for this higher decarbonization ambition. Now, why did we do two different ones here? The one is called distributed energy, and the story is more focusing on, say, a decentralized approach. Active customers who not only consume energy but also can produce it ourselves, for example. Small-scale solutions, circular approach. So everything happens very much at the local and regional level. And of course, that is that takes some requirements also from the grids. On the other side, we have the global ambition scenario, which is much more based on centralized solution, large-scale renewables, for example, big conversion of methane to blue hydrogen, or a very clear example is the large-scale wind at sea, for example, in the North Sea Wind Power Hub. That are the typical large-scale solutions that are included in such scenario, and that will also require a different use of the transmission grid in the electricity and in the gas. So this is the three scenarios that we have, say, developed. Yeah, the latter two, the both COP21 scenarios, were both also benchmarked with the European Commission long-term strategy that was published about a year ago. So, and we think that with these scenarios that are ways to test the infrastructure, that we are able to give, say, a robust testing of the electricity grid for its challenges, and also for the gas grid. Also on the gas side, taking into account that in the especially in the COP21 scenarios, that we already make the distinction between what is in methane and biomethane and what is in hydrogen. So these different gas qualities also now form part of our joint scenarios. Now, what we see in the scenarios is that, of course, the it's good to go to the next slide. What we see is that the interaction between gas and electricity is increasing, and of course, not only in the gas for the power generation, which is very important because you can have days that there is no wind and no sun, and it can prolong for up to, for example, 2 weeks. We even chose a term for this to honor the Germans with their early development of renewables, and we call it the Dunkelflaute. So that is a test scenario that we had to include. So gas for power is important, but also the power to gas is increasingly important because it is a way to get rid of some of the renewable generation that cannot be used as electricity then and there. It is also a way to to have a source of truly renewable hydrogen, green hydrogen sometimes called, and to transport and store that in the gas grids. So the energy system becomes more and more interlinked. On the slide here, you see on the left-hand side, you see the gas demand for power generation. The blue line is in the national trend scenario, and there you see the effect that in this scenario, compared to the others, we have a later phase out of the coal-fired power generation, the switch to gas, and also a lower overall generation of renewable energy. So And then you see that the demand for gas for the electricity generation is even increasing in the between 2030 and 2040. Now, another interesting effect is if you look at the two other scenarios, say the purple one and the light green one, that is the global ambition scenario is the green one. It can do with, say, a certain level of gas for power. The other scenario, with a much more focus on regeneration up to 80% is of the total energy is generated as renewable energy by 2050. It also requires a higher, say, use of gas for power generation in those cases where the rest is not available. Now, I'm not sure how far I am in the time, but I will come to a close. On the right-hand side, you see some what is important on the electricity side, and that is the level of electrification. Yeah, the level of electrification. So, and you see that both in direct use of electricity and in total, so also including the indirect, that our two scenarios, which are the blue and the green one, are, say, in the same range and partially even more ambitious than the comparable EU long-term strategy scenarios that are also to the 1.5 degrees. So we can say that our joint scenario work has been very interesting, and that, yeah, we already started the next cycle for the 2022 scenarios, and there are some points that we learned.
Thank you. Thank you, Anna. Thank you for this presentation.
But yeah, maybe I will talk about this in the next occasion. So thank you for your attention.
Thank you very much. I'm sure there are questions waiting for us in the Slido Q&A. So let's move to take some questions from the audience. And please keep pressing that thumbs up so that we get the top questions first. What could be the role for hydrogen produced from biomass combined with CCS, resulting in the badly needed negative emissions required for climate neutrality? Yeah, some people call this climate positive hydrogen. Who can I take this question to? Is this something, Jan, that you would like to take?
Probably not my area of expertise. But maybe Anna, do you have some comments to this?
Anna, otherwise I could talk a little bit about this. Anna, would you like to take
sure.
this?
Yeah, we see that indeed.
Anna, you're breaking up.
Yeah, we see that when you take the carbon budget approach. Okay, my microphone is on, but it's not good quality of the sound.
Yeah, you're a bit spotty, but please proceed.
Okay. Yeah. Well, now when taking a carbon budget approach, so cumulative emissions of greenhouse gases should stay under a certain level. Then you see that it is already very, very challenging to stay within this budget before 2050. That depends a little bit on how you calculate it. There are various ways to do that, but regardless, there probably could be an overshoot. And that means that already to be net neutral by 2050, you also will need these negative emissions. And after 2050, it will still be necessary to further go into negative emissions. So, and of course, there are various ways to do that. You can have the normal CCS, carbon capture and storage. But if you do this from the biomethane, this is, of course, yeah, in a way, a double contribution to such negative emissions that we certainly will need.
Thank you, Anna. Let's move to the next one. What is the role of the TYNDP and how is the line to 2050 climate neutrality? Dimitrios, would you like to take this one?
Sure. I mean, we've been talking about scenarios, and of course, in 5 minutes, we cannot give you details, but behind these scenarios, there are quite a few assumptions that are quite important. So, and I think they were hinted before a little bit. We're talking about the need for storage, either long-term storage or short-term storage. We're In our scenarios, we're figuring something like 25% increase of storage every year. We've been talking about flexibilities. In the scenarios, we have 6 to 7% of increased demand side response per year. The renewables, to reach 82% of renewables, be it offshore, onshore wind, or solar, or other renewables, again, these are tremendous increases. And we're reaching something in the order of 7,000 terawatt hours by 2050. So these are enormous numbers. The role of the TYNDP is to say how all these things are going to be working together, how we make this thing happen, what kind of regulated infrastructure do you need in place to actually neutralize these resources and give them value and make the whole system work. The TYNDP looks at it on an overall system perspective and identifies those grids that are the most cost efficient in order to make this thing work. That is the role of the TYNDP. It is aligned to the 2050 climate neutrality because the scenarios themselves are aligned to the 2050 climate neutrality. Thank you.
We have a bit more. Summarizing closing words. I would like to start with Bojana.
Let me just unmute the microphone. Thank you very much. Indeed, a very interesting discussion. As we are working, most of us, very closely together, I would say that from our perspective, the discussion was very interesting, and I and then GIE will agree of most of the things were said. Something to conclude, and I would assume something that many of the panelists will be also kind of agree on this, is that in case to have a kind of a fostering the competitive natural gas market in Europe, where we are sitting now, we should really have a stable and predictable regulatory framework. And the other thing which is also important is that we see that there is a need to have a technologically neutral approach to the carbon neutral energy transport and storage, which is something within the area of our activities. And as I see, there was a question on taxonomy, which was not raised, and taxonomy is a file that is very much linked to our activities, but we couldn't manage to tackle. And it's very important to talk that it's really a need and a must to ask for sustainable finance, which will be able to enable the future-proofing infrastructure to intensify, let's say, the construction of a new one, whatever is necessary infrastructure. That's from our side.
Thank you so much, Bojana. Jan, can I invite you to share some thoughts?
Thank you. Very short. Bojana put it very well, and what I would like to add to that is that I think we can all agree on the sector integration is very important, and conceptually it's hard to disagree on anything in sector integration, that we need to use the various assets in the best possible way, including across the sectors, including across the value chain. I think that we still need to have a lot of discussions on how do we do this nice conceptual, how do we convert this nice conceptual thinking into concrete doing, the practical parts of this, whether it's technical, whether it's market-wise, whether it's regulatorily. There we have still a lot of challenges ahead of us in doing this in practice. And then as the one message, and the other message in addition to what Bojana said, is I think I agree with Paolo on this about the digitalization. I think that is a big challenge for all of us to find the ways to utilize the digitalization in the best possible way. Thanks.
Thank you so much. Paolo Gallo, please, some thoughts from you.
Well, I'm starting where Jan has stopped because in order to have a complete and full integration to support the decarbonization path between electricity and gas, it is crucial, essential, the digital transformation of the networks. If you want to have that kind of integration, and for the gas sector, if you want to accept into our gas network biomethane and hydrogen, then you need to, first of all, to really transform the network into a truly digital one. So the effort of DSO and TSO, either in the gas and the electricity, has to finally invest in transforming those grids, those networks into a digital one. To me, that is the major challenge, and because it's a factor that will enable to do either integration, acceptance of biomethane, acceptance of hydrogen in our gas networks.
Thank you very much. Leonardo, can I ask you?
Yes, so, well, let me use my final words to connect again with the results of the poll that was saying infrastructure planning is key. So I think in infrastructure planning, we've always had a cross-border impact challenge, right? How to take into account the planning of one country on another. We are adding to it this smart sector integration challenge. And as I presented, on top of it, I think more and more we will see competition between networks and, you know, the market solutions like flexibility. So if we take all these three elements into account, I think it's great that the TSOs are collaborating and developing joint scenarios. And it's great that DSOs are also willing to step into that exercise. But at Florida School of Regulation, we just published a set of recommendations feeding into the 10E regulation revision. And maybe just to highlight one here, I think it's in the interest of everybody to have more transparency on these planning exercises. So one way of doing that would be to work with more open source modeling. That is because today we do not really know the kind of models that are being used in these exercises, or they're not yet fully available. At the national level, this has already been done by some TSOs. They even offer simulations that you can play yourself and say, in this kind of scenario, what kind of network would we need? So maybe some steps could be taken in that direction also at the European level.
Thank you very much, Leonardo. Dimitrios, please.
Yeah, thank you. I think we started all from the same departure point, which is electricity will be the bulk of the effort to decarbonize the energy system. Of course, there's a great role to be played by green gases. At the same time, electricity is also part of the decarbonization of the gas sector. And I do think that the composition of this panel is a bit symptomatic of the debate. It's like, well, there are no challenges in electricity. Let's decide how we decarbonize the rest of it. And what I want to stress here, that the challenges do remain, even at the high voltage networks. We're talking about 450 gigawatts of installed offshore wind. This is 3 or 4 times the size of France in the seas. How is this to be integrated into the system? So there are enormous challenges, and I can see that there are a lot of people coming from different angles, and they all converge. Okay, we understand electricity is in the center, so how each sector can help electricity, can provide more flexibility, coming from the gas storage, coming from the chemical battery storage, coming from demand side response, coming from energy efficiency, coming from whichever source. And I think this is a crucial thing, how the electricity, and in particular the electricity network, are going to make these things all play together, how we can achieve this overall system view to make all these things working together. As far as TSOs are concerned, for making this coming into play, we are and we should be quite agnostic. We are agnostic on who is going to provide the flexibility. All it's important is that this flexibility is there when you need it, and you can procure it in the proper way, in the most appropriate way, the most cost-efficient way. And the electricity infrastructure, the next decade is going to be critical. We're focusing in 2050, 2040. The next decade is critical for putting infrastructure on the ground. And I do think that forthcoming legislation should maintain the focus into doing that. And of course, sector integration, our approach with Entergy, to my eyes, has been an extremely successful experience, that what we have accomplished together with Entergy. I agree with Leonardo, this should be extended. We should integrate more of the DSOs. We should integrate more of different sectors like the heat sector and so on. This is our task. This is our ambition for the future. Thank you.
Thank you. Thank you, Dimitris. And finally, Anna, would you like to say a few words?
Yes, what can I add to all these wise words of you? I would like to say, yeah, changing our energy system away from the dispatchable fossil fuels that we know, the gas and the coal, and becoming dependent on much more intermittent renewables, which is our future. It will require that we have a good and robust and affordable system for that. And I'm convinced that certainly the cooperation between the electricity grid and the gas grid and all that's around, that the cooperation between those two is the only way forward to get to this. And we are increasing this now at the European level. We also see that this is required. It also will happen at the national level, that the gas electricity TSOs start more talking to each other and start more planning together. I've seen that in the Netherlands, there have been taken some steps, and other countries it is starting as well. So that in the end, both at national level and European level, gas and electricity will jointly cooperate to deliver this, affordable and robust energy system that we are looking for. That's what I'm, what I'm working towards.
Thank you so much, Anna. So we nearly reached the end of this session. Some great presentations. What I indeed also take away myself as moderator is that there is already a lot of collaboration between the gas and the electricity infrastructure sides, and there is an ability to do even more, and that is also probably necessary going forward. I hope that that all of you have appreciated this session. I would like to thank all the attendees for joining this session. It's been a pleasure to moderate this session. Thank you, big thank you to all the panelists. It is, of course, in such an online setting, normally we would have heard now a very loud applause. So please enjoy the imaginary applause for your contributions. It's been a great session. I would like to point out that there is a survey, a closing survey at the end of this session. So open for everyone, the ability to fill out the survey. With that, thanks again. I would like to close this session. Have a great day, everyone. Thank you.